For question number 36, part A, it's given that an electric iron consumes energy at a rate 880 watt when heating is at the maximum rate, and 330 watt of energy is consumed. That is when the heating is at the minimum. So the power is 330 watt. So source voltage is 220. We have to calculate the current and resistance in each case. So let's find out the current and resistance in each case. And this is question A, part A, and that is when heating is at maximum rate. So when heating is at maximum rate. Now then, so when heating is at maximum rate, so power is 880 watt. So power is 880 watt and source voltage is same. So V is 220 volt. We have to find the current and resistance in each case. That is, we have to find the current and we have to find the resistance in each case. So we know that P is equal to V into I. So power is 880 and potential difference is 220, and now current is 880 divided by 220, which is equal to 4 ampere. So current is 4 ampere. Let's find out the resistance. So resistance is equal to V upon I. So this is 220. Using the Ohm's law, we can find out the resistance. Resistance is V upon I. So uh, potential difference 220. Now current is 4. So this is 4 5s are 20. 4 5s are is 20, and resistance is 55 ohm. So resistance is 55 and current is 4 ampere in this case. So 4 ampere and 55 ohms is the resistance at maximum rate. Now let's find out move when heating is at minimum rate. So when heating is at minimum rate. So when heating is at minimum rate, what is the power? So power is given as 330 watt. So this is 330 watt and the potential difference is 220 volts. So let's use the same formula. We know that power is equal to potential difference into current. Power is 330, potential difference is 220, and we have to find the current. So I is equal to 330 divided by 22 and 3. So this is 1.5 ampere. Now we know that V is equal to IR. From here we can get resistance. So resistance is equal to V upon 3. V is 220. This is 1.5. So resistance is equal to 2200 upon 15. 5 3s are is 15. 5 4s are 24 0. And now resistance is 440 by 3 ohms. So 440 by 3 ohms. So this is 440 by 3, which gives us 3 1s are is 3. 3 4s are 12. 3 6 are 18. 3 6 are 18. And 146.67 ohms. Okay, let's move on to the next part. What is the heating effect of electric current? So heating effect of electric current means that the when electric circuit is purely resistive, when let's say electric circuit is purely resistive. So when electric circuit is purely resistive, electrical energy is continually dissipated. So electrical energy is continually, we say, continually dissipated in the form of heat. So that means we have complete resistance in the circuit and all electric energy is converted into heat. So electric energy is continually dissipated in the form of heat, which is called heating effect of electrical. So condition here is that electric circuit is purely resistive, and this is called heating effect of electrical, which is called heating effect of electrical. current. So this is what is heating effect of electric current. Now, okay, further is asked, find an expression for the amount of heat produced when it passes through a resistor for some time. This is Joule's law of heating. So the expression says that heat produced is directly proportional to the square of the current, directly proportional to the resistance and T. So this is the expression which is called Joule's law of heating. And remember, you will only be able to understand these things once you have studied the chapter. If you come directly to solving these questions, you may not understand the concept. To understand the concept, you have to thoroughly read your chapter, else you may not understand the concept behind this. So this is the Joule's law of heating. I have just given you the answers, what's written in the question. It's not the complete explanation or the concept of the chapter. So to understand the complete concept or to understand these questions completely, you will have to thoroughly go through the chapter itself. Let's move on to the next question.